Okay, so in question 12, looking at the context that's given is that there's a rigid container, and that's sort of a keyword, rigid container, like a keyword for constant volume process, containing n particles fitted with a valve. The valve is open for a period of time, and the number of molecules remaining in the container is n divided by 2. It is known that the temperature of the gas increases from 40 degrees to 80 degrees during this process. Which of the following are true? So looking at the values of Q and the values of work on the gas. So good question, the first sort of question, certainly in the review process, and it's quite different to some possibly the questions in the textbook, is that the number of n changes, so it's not a sealed container. So a container fitted with a valve that allows the n to change. So for a lot of problems so far and either gas processes, we think of the n as constant, if the process is done in a sealed container where n is not allowed to change, but here we definitely allow n is definitely changing. So the key, let's start here. If we think, I guess, about the first law of thermodynamics, so that's sort of the context here. Let's work on. Here we can sort of rule out some choices by thinking about the work. So it's a rigid container. So for a container that's rigid means that, in a sense, that's code word for that the container can't change its volume. So the delta V is 0. Not in process so much the delta V is 0, the work is 0. Just the work on the gas is equal to 0. So if you can't change the volume of the gas, there's no way for the work to be done on the gas, there's no way for the gas to do any work. So we can definitely rule out choices A, D, A and D. I'm based on this reasoning alone. So if you get a multiple choice quiz, instead of if you were to take a guess, 1 out of 5 versus 1 out of 3, just based on knowing that you don't have any work done. So that means that the first law of thermodynamics in this situation simplifies to Q. So this is true for isochoric constant volume processes. So to figure out what the sign of Q is, we have to figure out the sign of delta ETH, what's happening in thermal energy. So the thermal energy we will, up to this point, has studied that it's proportional to temperature, but it's also proportional to N. It's proportional to temperature only when you have N as constant. So the delta ETH is equal to 3 halves. In this case, I will do, maybe I should sort of stay here. I'll start with E thermal final minus E thermal initial. Just do one extra step. This is 3 halves of N final, Kb is a constant, T final, minus 3 halves of N initial, Kb a constant again, times T initial. So that's what we're looking at here. Now I picked some specific values for this question, so noting in a sense like the doubling of what seems to be a doubling of temperature. Of course, it's not an absolute value compared to the n's. So let's take this value again. So delta ETH. What I'm going to do is I'll write this 3 halves as n final as n over 2. Kb, and then the final temperature, or maybe I'll just leave that as the I'll just leave this final temp for now, and I'll do 3 halves of n Kb times Ti. So what I'm going to do here is take out the 3 halves n Kb piece in both terms, and then we'll see what we have left. So we have 3 halves, and I'm going to take out the n, and I'm going to take out the Kb. So I have T final divided by 2, so this 2 comes from this 2 here, multiplying, so sort of this is 3 halves NKB times Tf over 2, minus 3 halves NKB times Ti, minus Ti. Okay, so this quantity in the front of the parenthesis is definitely positive. So if we think about, so what we're down to this point, so the 3 halves NKB is definitely going to be a positive number. Now what it might look like if you don't do your conversions correctly, that 80 divided by 2 is 40, minus 40 is 0. You might think that E is the correct answer. But these temperatures must always be in absolute value. In the absolute temperature. So the 80 degrees must be converted to Kelvin, so that's 353 Kelvin, divided by 2, minus the initial temperature, which is 313 Kelvin. So this number is obviously is not the same as this one. It's much less. So we definitely have a negative delta T, and that's going to lead us to a negative ETH. So this is going to lead us to a negative 3 halves NKB times 137. This number is 137. The number isn't really important, but it's the sign that's important. So this quantity price is negative, meaning that we have a negative chain of thermal energy. So in order to have a negative chain of thermal energy with no work done, the Q must be negative. So the correct answer here should be choice B. That's the correct answer. So what's happening in this process is likely that you place the gas in contact with something. So again, the initial temperature is 80, so place it in contact with a colder system, while so even though in a sense it looks like the temperature is increasing, but here we're going to include the changes in the number of molecules. So we in this case the Q has to be negative, so they have to be placed in contact with something that's colder, so to remove. So Q is negative, which means that thermal energy leaves the gas. So this is just one of those more challenging problems in where N is changing, where 9 times out of 10 or more, in a sense, these processes will take place in sealed containers, but this is the type of problem where we add an additional variable to consider during a process like this. So choice B is the correct answer.